8.4, divide and multiply rational expressions. This is going to be just like multiplying fractions, as we should be familiar with. When you multiply fractions, you can cancel, cross-cancel, and then multiply what's left across the top, multiply what's left across the bottom, and you're done. Today we're going to do that with rational expressions. So this kind of summarizes what I just said. It tells you that you can cancel things out if they're on top and bottom, as long as all of the factors are multiplied. Down here is kind of what we're going to see today. There's an x plus 3 on top and bottom. We cancel them out. Move on. So first example, I notice nothing looks the same on top and bottom. That's because we haven't factored yet. I recommend you practice factoring this using Clinton Magic or whatever technique you like. Pause the video. See if you get the same thing I do. So for the top, I see negative 15 goes on top, negative 2 on the bottom. X and x, two numbers that multiply to give negative 15, add to give negative 2. Nothing reduces, so I write x minus 5 times x plus 3. The bottom of this expression is a difference of squares, so I can use that technique. Now that I'm fully factored, I can cross out x plus 3 from top and bottom, and I'm left with x minus 5 over x minus 3. I can't cancel out the x's because you can only cancel out factors. And x is not a factor of the top and bottom. Common mistake is to try to cross off those x's. So go ahead and pause the video and try 1 through 6. A few of them are already factored for you. Some of them you have to factor. So now we're going to look at multiplying two expressions. This is where we can cancel things out. For instance, I see this x squared and an x, we can cancel something out. I see a 5 and a 10, we can cancel something out. And all that work is over here. Cancel out anything you can, and then you get your final answer. So let's take a look at one of these. I'm going to rewrite the problem bigger so I can cross things out without clutter. I recommend pausing the video and finding things to cancel out yourself before I do it. Okay, first I'll look at my y's. I see I have a total of 4 y's on top and 3 y's on the bottom, which is going to leave me with 1 extra y up top. Then I look at my x's. I see that I have 7 x's on top, 3 and 4, 7, 1 x on the bottom. If 7's on top, 1's on the bottom, that's going to leave me with an extra 6 on top. Looking at my numbers next, I see 2 and 8, they reduce. 2 goes into 8 4 times, 2 goes into 2 1 time. I can also cancel diagonally. I still see that 4 on top. I can cancel with that 4 on the bottom. 7 doesn't seem to cancel with anything, so I leave a 7 on top and no number on the bottom. So there's nothing in my denominator. 7x to the 6th, y. Choice B. Next up, we've got another pair of fractions being multiplied. We want to cancel things out. But before we do that, we have to factor. So looking at that 3x minus 3x squared, before I try anything like Clinton Magic, you're always supposed to check for a common factor. And there is one. 3x comes out of everything. 3x goes into 3x 1 time. 3x goes into 3x squared. X times. On the bottom, we have to do a little side work. Clinton Magic. Negative 5 times 1 for the top, 4 on the bottom, x on top. Two things that multiply to give negative 5, add to give 4. So negative 4 and negative 1 works. So we can write our factors. We have to do Clinton Magic again, or whatever method. and we get our factors. There's a lot of work going into factoring. 3x doesn't factor, we just leave it 3x. Now we look for things that cancel. I see an x minus 4 on top and bottom. I see a 3x on top and bottom. And this is actually something too. Notice they look kind of the same. There's a property that says if you have two numbers subtracted on top, the order switched on the bottom, that's always going to give you -1. Practice it with a couple of numbers if you want to verify. But that's what's going on here where I circled in blue. 1 minus x over x minus 1 will always reduce to -1. Looks like all that's left on top is the -1 times x plus 5. Nothing left on the bottom. And we're done. Side quest time. A little proof that a minus b over b minus a is always -1. The way we could prove that is rewrite the bottom. Switch the order there. Now let's factor a -1 out of the bottom. As you can see, the a minus b now cancels out. Left with 1 on top, -1 on the bottom. Done. It doesn't matter what a and b are, as long as they're in this form. Next up, another time we're multiplying two fractions together. If you don't see a fraction on one of your expressions, just put it over 1. We might try factoring that x squared plus 3x plus 9, but it's actually probably not going to work out. 9 on top, 3 on the bottom. Two numbers that multiply to give 9, add to give 3, doesn't happen. However, obscure reference to something that you might not remember, difference of cubes formula. If you don't know your sum and difference of cubes, go back to your notes and review them. They're fair game. This is a difference of cubes. A equals x, b equals 3. So I'm going to factor that denominator, x minus 3, x squared plus 3x plus 9. Now something interesting happens. X squared plus 3x plus 9 cancels out. X plus 2 or x minus 3 do not cancel out, so they're part of our final answer. And we're done. Let's go ahead and pause the video and try some of these. You'll have various factoring techniques that you're going to have to use. I see greatest common factor. I see difference of squares. I see difference of cubes. Maybe Clinton magic. Try your different factoring techniques. Simplify all of these. Our last big topic is division. Remember that when you divide fractions, all you do is flip the second fraction and change it to multiply. Other than that, this is exactly the same as multiplication. So let's take a look at this. I see division, so I know I'm going to flip that fraction over. As I flip it over, I might as well factor it. 7x does not factor. 2x minus 10. Before I just give you the answer, why don't you pause the video and try to factor all of these on your own. If you thought that 2x minus 10 factors by taking out a 2, good job. Changing that divide to a times, which means I'm going to flip my fraction. So first I'll factor this guy. It looks like it's a Clinton magic problem. Two numbers that multiply to give 30, add to give -11, -6 and 5. Again, I'm flipping, so this now goes on top. On the bottom, you can't use Clinton magic, that x squared minus 6, but there is a GCF. Take out an x, and I'm left with x minus 6. Now it's just like the old problems. We look for things that cancel, x minus 6, x minus 5. One of the x's cancel. All we're left with on top is 7. All we're left with on the bottom is 2. So that big mess simplifies to just 3.5. One more of these. Again, if you don't see a fraction, you can make it a fraction. Pause the video, factor all of these as best as possible. Don't forget to flip and cancel. Looking at my first fraction, looks like I'm gonna have to do some Clinton magic. 6 times negative 15. 1, two numbers that multiply to give negative 90. Add to give 1, don't forget to put 6x on top. I think the numbers that work are 10 and negative 9. Both of these fractions reduce. This guy reduces to 3x over 5. This guy reduces to 2x over negative 3. So I can start writing those factors out now. 3x plus 5, 2x minus 3. The bottom, 4x squared, does not factor. It's already factored. Because I'm flipping, the 1 now goes on top. And it looks like I have a GCF. I see x in both of those terms. So I take it out and I'm left with 3x plus 5. Now the game is just cross out what I can. I see a 3x plus 5 on top and bottom. I don't see a 2x minus 3 on top and bottom, and that's all. So it looks like I'm left with a 2x minus 3 on top and 4x cubed on the bottom. Don't try to cancel out any of these x's because they're both on the bottom. They don't cancel, they multiply. That's it. At this point, go ahead and pause the video. Try these on your own. Some tips: put things over 1 if they don't look like a fraction. Use Clinton magic where you need to. Look for a GCF where you need to. And cancel anything you can. Have a nice day.